The first order and first degree ordinary differential equations also finds its application in the finding of the isogonal trajectories of the families of curves. So if we let f of x, y, z equals 0 be a given one parameter family of curves, a curve that intersects the curves of the given family at a constant angle alpha, and we have to take note that this alpha right here is not equal to 90 degrees. Because if that would be equal to 90 degrees, then that would be an orthogonal trajectory. So a curve that intersects the curves of the given family at a constant angle alpha, which is not equal to 90 degrees, is called an isogonal or oblique trajectory of the given family. So just like what we did in the orthogonal trajectories, we are given or we are to determine the equation of the family of curves, and after that we are to determine the differential equation of the family, and using that differential equation of the family, we find the dE of the isogonal trajectory this time and solve that dE to find the equation of the isogonal trajectories. The only difference with the isogonal trajectory from the orthogonal trajectories is that the angle between the curves is not 90 degrees anymore. And so to be able to find the dE of the isogonal trajectory, we're not going to find the negative reciprocal of the slope of the dE of the family anymore, but instead we're going to use this equation right here. So tangent of the angle between the curves is equal to m sub 2 minus m sub 1. So m sub 2 and m sub 1 here are actually the slopes of the tangents of the curves. So m sub 2 minus m sub 1 over 1 plus m sub 1 times m sub 2. Or if we're going to write that in terms of dy dx, then if we let dy dx sub f be the slope of the family, and we let dy dx, let's say for example I sub it, is the slope of isogonal trajectory, then the equation given would now be tangent of alpha equals the slope of the isogonal trajectory. So dy dx it minus dy dx, or the slope of the family, over 1 plus dy dx f, that's the slope of the family, and then dy dx, that's the slope of the isogonal trajectory. So we're going to use this to find the dE of the isogonal trajectories, then we can solve that dE to find the equation of the isogonal trajectories. So, for example, we are to find the isogonal trajectories intersecting at an angle of 45 degrees to the family of hyperbolas x squared minus y squared equals c. So we're going to follow the steps that we did before. So step number 1, of course, we're already given our equation of the family x squared minus y squared equals c. So we're going to find the dE 2x minus 2y dy dx equals 0, such that dy dx is equal to, okay, x over y. So this is now the slope of our family. So after that, we are going to find the slope of the orthogonal trajectory. So tangent of alpha equals dy dx of the isogonal trajectory minus dy dx of the family over 1 plus dy dx of the family, and then dy dx of the isogonal trajectory. So our alpha is 45 degrees, so tangent of 45 degrees is equal to dy dx minus our dy dx of the family is x over y, so minus x over y over 1 plus x over y dy dx. But we know that tangent of 45 degrees is just equal to 1. So 1 equals dy dx minus x over y over 1 plus x over y dy dx. Then that would now be equal to 1 plus x over y dy dx equals dy dx minus x over y. So we are going to multiply both sides of the equation by y dx. That would give us y dx plus x dy equals y dy minus x dy. And the left side is an integrable combination. That would be the differential of xy equals y dy minus x dy. So all the terms are already integrable. So integrating, we get xy equals 1 half y squared minus 1 half x squared plus c sub 1. And so if we transfer this to the other side and this one to the right side, and then multiply both sides of the equation by 2, or we can just transfer here, left side, multiply by 2, we get x squared plus 2xy minus y squared equals c, wherein our c here is equal to twice of c sub 1. And so this is the equation. This is the equation of the isogonal trajectories. And let's try to see what type of curve that is. So using our discriminant, b squared minus 4ac. So b, our value of b here is 2. So that's 2 squared minus 4 times 1. And our value 1 here and c here is negative 1. So that's 4 plus 4, that's 8, is greater than 0, meaning it is a hyperbola. So we can therefore say that the isogonal trajectories to the given family of hyperbolas is also a family of hyperbolas, and they intersect at an angle of 45 degrees. So this is our answer: x squared plus 2xy minus y squared equals